In this lab, you will be experimenting basic 2-transistor current mirror and the Widlar source. In the basic 2-transistor BJT current source, the reference current is mirrored back to the output. So I out is roughly equals to the I in, provided that these two transistors are matched. In the experiment, you will be establishing the reference current using a resistor and a power supply. Here, to examine different currents, we will be using a staircase function so that for each step from 1 to 5 volts, you will be calculating the measurement current here, the reference current, and then measuring the output current. Now, to measure the output current, we are going to use the resistor 2. Since we don't have any option to see the current waveform, we're looking simply at the resistor 2 waveform. So channel 1 goes across R1 resistor to observe the input current, and channel 2 plus and 2 minus goes to the across resistor R2 to measure the output current. And we should see the waveform here is matching the waveform over there because there should be roughly equal. So you should expect to see 0.7 volt less than what is applied. So if this is 4 volts, you should observe 3.3 volts here and roughly the same on this resistor. So the experimental setup is explained here. So you got this stair-step file provided to you. You can simply use it and set it with these parameters. So this will be varying from 0 to 5 volts in step up 1. So when you observe the two waveforms, it should roughly look like this. So the blue one is the one on the output. So it should roughly correspond to the input waveform. So what we're measuring are the resistor voltages. So if you can view this as the currents, if you just think this is a milliamp, so you got like 1.5 milliamps here, maybe 2.4 milliamps. In other words, this indicates that output current and reference current roughly equal to each other. Of course, the transistor matching is important, so we're not going to have probably a perfect match here. And also keep in mind that output current tend to be a little less than input current. In the second part of the experiment, you will be working on the Widlar current source. Now, ignoring the staircase function, the Widlar source looks exactly like this one, except that there is an emitter resistor on the output part. Now, this will make output current a lot less than the input current due to the presence of this resistor. So if you remember, Widlar source is a good fit for obtaining low output currents. In this experiment, we are using simple 5 volt source at the reference part as well. So we'll be simply looking at the voltage across R1 and R2 to get an idea on the currents. So instead of using various levels of input DC. So what we measure here will be voltage on R1, and simply you can simply divide that by 1 kilo ohm to get the currents. And in this experiment, before we run this experiment, we have some pre-lab work needs to be done. First of all, you need to do hand calculation. When you pick the resistors for your experiment, make sure to measure it and try to pick values that are very close to each other. So pick two resistors, 1002 and 1004, something very close. So try not to use one resistor at 997 ohms and another one is 1007. So because of the tolerances, so you might have this. So we want to have good reading and good matching. So based on the measured values, you're gonna do the hand calculation, and then you will use those exact values and construct this multi-sim circuit and simply put a current probe to measure the currents. So we will be comparing this against the reading in analog discovery, and what you get with the analog discovery is this simple window, and I would read this as 4.3 milliamps and this one as 0.1789 milliamps. Since we're measuring voltage, what I did is just simply divide by 1K, and that's my current readings right there. And then you get to answer these questions at the end, which is asking you to compare the simulation, hand calculation, and then the measurement results and explain the differences. Thank you.